Alright, we are continuing with our stoichiometry problems that are simple one-step stoichiometry problems. We're going to do example number 2, and a friendly reminder, we are writing these in our notebook, page 106. I decided to do a second video because these are gonna be long, so that you can pick and choose what you want to look at. Alright, so here's example number 2. And this question says how many atoms are in 0.3 moles of mercury. The process isn't going to change, right? We're going to list our knowns and our unknowns. So our known is whatever they give us. So 0.3 moles, that's mole, of mercury, which is Hg. And our unknown is whatever we're looking for, so atoms. So question mark, atoms, mercury. Time to pick our conversion factor again, so we want to pay attention to our units. So let's start here with this one. Now, we get a little closer. We're only doing one step, so we can just pay attention to the A side. Right? So particles are atoms, right? They have the little atoms or molecules here. So here's our atoms, and we're going to mole or mole to atoms. So we're going to use Avogadro's number. And we have the same thing right here. And this was a reminder that these are more common words than particles. So to get from moles, here it is, to get from moles to particles, we're going to use Avogadro's number for a conversion factor. Now again, I don't know what direction I am going to need that conversion factor, but I'm just going to jot it down. 6.02 times 10 to the 23rd. In this case, it's going to be atoms, and that is equal to 1 mole. We're going to set up the known as a fraction. I'm going to put the 1 right there already, times the conversion factor, and it's going to equal whatever we're looking for. I have numbers and units for both sides of my conversion factor, so I don't actually need to do any extra work like we did in example 1. 0.3 mole mercury is my known, so I plug that in right there. Now my conversion factor again, I've got atoms and I have moles. The reason why I'm paying attention to the units and not the chemicals is because my chemicals aren't changing. So if mole is written on the bottom, I'm going to write 1 mole also. I'm not on the top, I'm going to write it on the bottom so I can cancel out my like terms. Do notice that I deal with the unit I'm starting with, or whatever like term I want to cancel first, because if I can place that in the correct place, I'm left with one spot, and I have one thing left over, and I can just fill it in. Atoms, Hg. Now I'm going to cancel out my like terms. Now in one-step problems, it might seem a bit silly to cancel out like terms, but pretty soon you'll be doing multi-step problems, and it's very helpful if you cancel them out. Alright, 0.3 times 6.02, second function, 23, and then divided by 1. I'll use the unknown color. I have 0.3. The leading zeros are not significant, so I can only have one significant figure. I have 1.8 in my calculator, so 2 times 10 to the 23rd atoms mercury is my answer. I just converted using Avogadro's number between moles and atoms.